Nope, so we can come over here now. I think we're recording. Yep, we're recording this. So we can come over here and we can erase this one. And that one's, so we got a formative tomorrow.
Rewrite the bottom one.
Yeah, what happened down there?
I don't know.
Hi, caramba. So we got a formative tomorrow, and then that's it this week. And then we've got a quiz next week. Love it. All right. So formative tomorrow is all we got this week. And homeworks. Oh, side note. Homeworks are going to be out of the book today.
So find your book.
Find your book. Which is a good plan because if you don't turn in your book in like a couple weeks, it's $50.
4 weeks exactly.
4 weeks exactly. What's up, LB?
So that's homework due every day, like the following day?
Yeah. So this homework will be due on Wednesday. Yeah. All right. So changing form of conics. Love it. So you have all of this written down. Okay. You might have it all written down in a bunch of different places, but it should all be somewhere in your notes. Okay. So the general form of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, that's the general form of a circle. An ellipse, we have x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. Parabolas look like that. 2 different forms. Depends on which one's squared, but basically the same style of form. Hyperbolas look like that. Again, depends on if it's up, down, or left and right as to which one comes first. Okay? So you got all that. Okay? Now, on the... I was going to say on the what? Okay? So on the face, if I were to ask what the difference between all of those are, what would you say? Like, what's one thing, one observation, seeing all 4 of the conic section formulas, forms, if you will, in front of you now, on the face, what do you notice? What are some observations that you see? Yep, with all, like the differences between them all.
You got it there?
I'm good. Whew. I was exhaling while I was drinking. That ain't good. It's a one-way street.
It really is.
Like I was here and I started to exhale. I don't know why my body started to exhale, but then the stuff was in the mouth, and I'm like, okay, now I got to go somewhere with the stuff that's in my mouth while the stuff's got to come out. I made it through though. I'm a trooper.
You really are.
Gamer. Anybody see anything? No? Maybe not. Okay. Like, how to tell the difference between each one? Yeah. Differentiate. Okay.
Yes.
All right. Well, here's one thing. Right? Does that make sense? Parabolas are the only ones that have one squared term in them. All right. Let's go back a slide. Circles have 2 squared variables. Ellipses have 2 squared variables. Hyperbolas have 2 squared variables. Parabolas only have 1. Yes? Okay, so that's one way to differentiate between a parabola. Parabolas only have 1 squared variable. Okay? Let me go back to this one again. What else do you see? There's one other big glaring one that should be popping out for you. is the difference between?
We got
Yeah, no. We already took care of parabolas. But that's just a number though, so that's really not a variable. Okay? But yeah, I would have 3 squares. One big takeaway.
hyperbolas have subtraction.
Hyperbolas have subtraction signs. The other 2 over here, circles and ellipses, are adding. Right? Okay? So another big one is that hyperbolas is the only one where subtraction sets apart the squared terms. Okay? So then that leaves us with how to tell the difference between a circle and an ellipse. How would I tell the difference between a circle and an ellipse? Okay? Like, what do you mean R? Okay? Way back, I shouldn't say way back, well, 2 weeks ago. 2 weeks ago, we were talking about ellipses. I said one key thing that day. First day, day 1 of ellipses. And it had something to do with A and B. Anybody remember what the key thing that makes an ellipse with A and B? They can't be the same. Okay? They can't be the same. Okay? So they have to be different. Okay? Because if they were the same, it becomes a circle. Right? Okay? So to put that into words in a different way, one way is to say that when the equation is set equal to 1, the denominators below the x and the y terms will be equal if it's a circle, different if it's an ellipse. Okay, that's why we said it before. A and B are the same, it's a circle. A and B are different, it's an ellipse. Okay? Another way of saying that same thing is that it's an ellipse if the coefficients on the squared terms are different. Because that's saying the exact same thing, okay? But in a much more compact, concise way. Okay? The reason that we have to know those differences or ways to differentiate between them is because of how the problems now are going to look. So I'm going to pause the video here for a couple of seconds because I feel as if you guys didn't write this stuff down. Okay? And it's kind of the important part of today. So if you're watching along on the interwebs, here is where you would pause, write this slide down. If you're sitting here in a desk, here is where I'm going to pause and you're going to write this stuff down. And we're still writing. Did you pause it yet? I bet you paused it now. Here in class, we're just waiting on the one who's writing an orange pen. Good now?
Wonderful.
Awesome. All right. So here's the why. Here's the reason why. Because now this is going to be a problem. Right? That doesn't look like any of what those other ones looked like before. So how are we going to be able to tell what conic is represented by each equation? Well, it's the stuff that you just wrote down. Okay? If there's one squared term It's a parabola. So which one of those four is a parabola? C is the parabola because it's only got one squared term. A hyperbola has the two squared terms separated by a subtraction sign. Which one of those three now is the hyperbola? A, because it's got the subtraction sign. Circles and ellipses. Circles have the same coefficient on the squared term. Ellipses have different coefficients on the squared terms. Which one's a circle? Which one's an ellipse? D is a circle. Why? Because they're the same. Which means B is an ellipse. Because 4 is different than 1. Okay. Now, on Wednesday, we're going to learn how to change equations that look like this into our standard form of a hyperbola, of an ellipse, of a circle, of a parabola. Because then we can graph it. And we can find all the extra stuff that we have to find. Okay? Today, what I want to focus on is I want to focus on writing equations. Okay? We're going to write equations of all the different kinds based off of certain conditions. Okay? So, for instance, circle with a center at 3, -2 and a radius of 4. Well, it's a circle. So the equation is going to be x minus h quantity squared plus y minus k quantity squared equals r squared. Right? What's h? 3. Well, 3 is h. What's k? -2. And what's r? 4. Okay? So we can put that into play then, and we can say that this is x minus 3 quantity squared plus y plus 2, because really it's minus -2 quantity squared, equals 4 squared, which is 16. Okay. Should have made it radius 14. Mm-hmm. Fleet Farm tire guy. 13 on 14.
Oh, now I missed.
With me?
I was confused.
I got you. All right, find me the equation of a parabola with a vertex there and a focus there. Go for it. All right, so I got a vertex. So if I make myself a little chart, I got a vertex over here, and I got a focus over there. Right? So which way does this parabola open? To the right. Okay? So a right opening parabola has y minus k quantity squared equals positive 4p times x minus h quantity. Agree. Okay? What is k? Negative 4. What is P? What is P? P is the distance from the vertex to the focus, right? What is that distance? 6. What is H? Negative 2. So this really is y minus, y minus negative 4 quantity squared equals positive 4 times 6 times x minus negative 2. But to make that look nice and pretty, that's going to be y plus 4 quantity squared equals positive 24 times the quantity x plus 2. Yes'm?
Yes, sir.
Huh? Oh boy. Find me those two equations. Go. Alright, so we got an ellipse with vertices at there and there. So if I draw myself a little picture again, that tells me that I've got a vertex at negative 1, 5 and 7, 5. So I got vertices like that. Okay? And foci inside of there. So at 1, 1, 5 and 5, 5. So they're kind of like that. Okay? So based off of that, where is the center of this ellipse? Three, 5? Yeah. Okay. Could have taken the midpoint of the vertices or the midpoint of the foci. Okay. With that being said, this one is going to be an x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Okay, like it? So if my vertex or my center is in there, then that makes this be A, right? Which is how much? How much? 4. Yep. Okay. So A is 4, which makes this be C. How much is C? 2, right? Okay. Now, the formula was c squared is equal to the absolute value of a squared minus b squared. Okay? So c squared is going to be 4. A squared is going to be 16. I need to figure out what b squared is. So 16 minus what gets me 4? 12, right? Okay. So b squared has to be 12. Do I need what b is?
No.
No, I don't need b at all. B squared is fine because that's what's going to go in my formula, or my form. Okay? So now I have enough. So now it can be x minus 3 quantity squared all over a squared, which is 16, plus y minus 5 quantity squared all over b squared, which is 12, equals 1. And that's the equation of my ellipse. Same goes here for the hyperbola. Okay. So now I've got vertices at 7, negative 3 and 7, 1. I've got foci at 7, negative 6, and I've got foci at 7, 4. So where is the center? Where is the center? 7, negative 1. I like negative 1 better than negative 2.
That was
Okay.
just a break.
I understand. Okay. Which way does this hyperbola open? Up, down, right? So that is going to be an y minus k quantity squared all over b squared minus, oops, I almost put equals there, minus x minus h quantity squared all over a squared equals 1 type 1. With me? Okay. So this distance here is b. What is b? What do you got? 2. This distance here is c. What is c? How much? Nope. Distance from negative 1 to 4 or negative 1 to negative 6? 5. C squared is going to equal a squared plus b squared because we're a hyperbola. So 25 is going to equal a squared plus 4. So what's a squared? 21. Do I need to find a? Do I need a? Nope. Okay. To the formula now. Y plus 1 quantity squared all over 4 minus x minus 7 quantity squared all over 21 equals 1. Yes? Love it. I know it's out of textbook. Woohoo! 4 problems, 2 days. I think you can handle it. Plus a formative tomorrow. Okay? So this one will be due on Wednesday, and yes, I will straight up collect it